Hey there.
Vijay, how are you?
Hey, good. How about you?
Good, good. It has been an extremely busy week, so looking forward for the weekend.
Oh yeah, yeah. I um I don't blame you if you didn't get chapter one done. It's something we can probably do together. I um I feel like sometimes like when I think about these meetings, I
Uh-huh.
feel like this is like the time for us to try to read the book.
Yeah, that's true. I read probably 20 or 30 pages in chapter one. It was a quick read.
Yeah,
I think this book is not very deep in the first few chapters. Probably they
yeah,
just briefly say one liner about the concepts we read in DDIA.
yeah. I agree
Yeah,
with you.
yeah,
I
yeah,
think as long as, it's ultimately like we're just a group that is
yeah.
interested in, like doing this, right? Like we're
Yes.
interested in rather than reading alone, we're interested in reading together. And I
Yeah.
think that's a good thing, like some people um want to study that way and I definitely do. I think when we study this way, like we all kind of learn a little bit more together. So I'm okay with that.
Yeah, definitely. Like even for I moved jobs a year ago from a startup to my current company,
Hmm.
and having a study group during the interview process was very good. It was not only for accountability, but also sharing the journey. Like
Exactly.
failures are not common. This is what you need to do, what the other person is bringing into the table. So yeah, I had a great time with my study group last year.
Yeah. And one thing that I've noticed, I know we're waiting for others, but like the people that follow on LinkedIn
Mm-hmm.
who are like, way up there or they're working at,
Mm-hmm.
Meta or like, these high positions in Netflix or whatever, all of
Mm-hmm.
them, all of them have like good mentor systems. Like that's something I like have noticed very, very often. Like they have a very good mentor resource.
Definitely, yeah. Anybody who has been very successful and higher up in staff, senior staff, or architects, they've had mentors in their careers, or
Yeah,
they've been in companies which were growing at a rapid pace, so they could learn a lot of things within a short time frame.
correct. Yeah. Even Krishna too, right? Like he always says he has very good mentors. He's very thankful for that.
Yeah, yeah. Unfortunately, in my company, I every the team flux is quite frequent and churn and all those things. I've been unable to find a mentor. So yeah, I've been looking out for some external technical mentorship. I have like
Yeah.
other mentorship through, I volunteer through Women in Machine Learning and Data Science
Hmm.
group. I'm a co-organizer, so I get to get non-technical mentorship from someone there, but
Hmm.
technical is where I'm still looking for someone.
Right. I think like it's just about doing these kind of things. I mean, like the more I also talk about it,
Mhm.
you know, um, and I could start like trying to like mention it more like in the group that I run, but
Mhm.
the more that I just kind of say that, oh, I have a study group, the more people like gain interest in it. And
Mhm.
then I think like it brings good people together, including like yourself and Karthik, and then Karthik knows like a whole bunch of other people too on top of that, that he's been introducing me to. And even Amelia, is pretty
Yeah.
good. So I feel like we're a good team and it's only gonna get better down the line.
Definitely, definitely. Yeah, I was also like thinking probably I'll reach out to Karthik. I've not been a part of the Krishna's group. I joined here because I knew Amelia.
Oh, okay.
So I wanted to probably later sometime reach out to Karthik and see if he's open for some technical mentorship or yeah, through him have some. I'm also in machine learning area, so I wanted to get to someone who is in machine learning and been there for did some systems. So it's hard to find somebody in machine
Have
learning.
have you checked this group? There's another person in here named Jordan.
Uh,
Um,
uh-huh.
Jordan Peer is a ML guy, and I guess like he's been saying that he wants to come to these meets, but
I
he doesn't
see.
have the time. So he just
I see.
watches it on YouTube.
Mhm.
But he's a very good, he's very interested in ML. And every time, well, I'm connected to everybody pretty much now on LinkedIn. Like, so every time I see an ML post, like the top
Yeah,
people that usually
yeah.
like it, it's Manny and Jordan. So
Manny and Jordan. Okay,
yeah,
I'll go and look that up. Yeah.
so I don't know. You could also, if I like somebody, you probably could follow that
Yeah,
person's page.
definitely. Yeah, definitely. Yeah, that would be great. Yeah. Yeah.
So okay, I guess people are a little late today.
Yeah. Yeah. We can
Just get
yeah,
started.
get started. Yeah, it's 10 minutes, close to 8 minutes. Yeah.
Okay. All right. Well, like I said, I think like the strategy for us, and feel like this can be like a default strategy if we didn't read or if we're kind of like behind in reading, just use the time to read.
Yeah. Makes sense.
So, okay. Like for me, I was reading through this and I was just trying to get a sense of like what does Alex talk about. So
Mm-hmm.
this one seems like it's more practical, whereas
Yes.
the other book felt more extremely theoretical.
Yeah. Agreed.
So,
Yeah.
mhm. So I feel
Uh,
like this is probably something that we want to just kind of like use like when we try to attempt, questions on our own. But let's see. So
yeah. This one is a little more relatable. The other one is very deep in some content. Unless you are an architect working in that particular area, it's difficult to piece together all the technical contents without. Yeah, I understand.
yeah, yeah. I mean, I feel like for that book, right?
Mm-hmm.
Uh, most people who work in web development, engineering, and all that
Mm-hmm.
probably won't go that deep unless like they're directly working in that space. Like a lot of it gets so deep that it goes into like PhD level, right? So like
Definitely.
I don't think like it's good I feel like it's good to just have like a basic understanding,
Yeah.
but I
Yeah.
feel like it's to be like questioned deeply on it and then say, oh yeah, I know this. That would actually result in it look like you were lying or something,
Yeah.
in an
Yeah.
interview.
Yeah. That's true. It's always like good to know information. Hey, why do they do replication? Why do they do partition? So, what are the high
Yeah,
level ways of they do it? And yeah. So.
yeah. So, all right. So I think like this chapter kind of mirrors the other one. We were talking about scale in the other book,
Mm-hmm.
and scale is
Yes.
kind of like the same
Mm-hmm.
concept,
Mm-hmm.
here.
Mm-hmm.
Um, so this one, basically, like I was kind of going through the first few pages last night.
Uh-huh.
Um, and so like I kind of got to the part where, like it's it's basically like about this chapter is about like serving millions of users. He talks
Mm-hmm.
about like a server, like what
Mm-hmm.
it is, a DNS, you know um, domain name service, like
Mm-hmm.
somebody requests like a URL, they get an IP address,
Mm-hmm.
then that IP address points to a machine, the machine returns some HTML, CSS, or JavaScript.
Mm-hmm.
Um, and that could be done on a web browser or a mobile browser. And
Yeah.
then basically, you can see the web server here. Like this
Yeah.
is what basically returns back content. So,
Mm-hmm.
and that's what this thing says here. Figure illustration 1.1 is single server setup, where everything is running on one server, a web app data. But the thing
Mm-hmm.
is, like, no modern site, well, unless it's a small site, right? Like most of the big tech sites don't look like this.
Yeah.
It's very, very different. This is
Mm-hmm.
like your most basic website, probably like fine, right? Like
Yeah.
the personal portfolio site I have. So,
Yeah.
let's see here. This is kind of like again, iterating that detail. Says
Yeah.
users access websites through domain names.
Mm-hmm.
So I'm going to highlight DNS. Just in case you didn't know, IP is also a common term that I hear in interviews. So what's the IP?
Mm-hmm.
What is hypertext protocol, transfer protocol? And then, like there are other protocols to be aware of later down the road. But HTTP and HTTPS are most popular. Web server returns HTML or JSON responses. Then it says web application, right? Web application is a combination of server-side languages like Java or Python, which handles business logic, storage, etc., and client-side languages for presentation. So, like a lot of times when people, I've heard this in interviews, like some people will say, "What's the difference between a website and a web application?" Right? Like, because for people like me, a lot of people like think when I say, "Oh, I work on websites," they're like, "Oh, you work on websites?" Like they just think, "Oh, isn't that kind of easy? Like I could do that too." And I'm like, "It's not easy." And I'm like, "Why?" And they say, "Aren't you just like making like simple pages in HTML and CSS?" I mean, I was learning that too. And I'm like, well, yeah, HTML and CSS is easy, but making a website is very different. And sometimes it's not just a website, it's a full-on application, and at that point they'll get confused because they won't know what an application even means. We'll say, so you make an app? I'll say, yeah, like a full program. So I feel like this explains it pretty well, right? Like it's not just the HTML, CSS, it's the combination of all the languages that put together the business logic and the storage part, the saving part.
Yeah.
So I think like when people understand this definition a little bit better, they're like, okay, yeah, I see why you are paid so much money or whatever, and maybe I should back off. It's like this is very difficult. Yeah. And then going along that vein, right? Web developers aren't just responsible for the site, we're also like responsible for like the other applications as well, right? Like there are mobile applications that go into development as well. And even just like the back end, creating like the RESTful servers to save and update and then present data is pretty difficult too. So these are the important parts. By the way, I see Sadhana joined. Sorry, didn't want to ignore you.
No worries. Hi Vijay. Hi Ramya.
Hi, Sadhana.
Hey. So just giving you a quick feedback here. We're just reviewing this system interview book by Alex Xu. We were kind of like a little bit busy this week, and so like we're using the time to read the book now, essentially, because I think like sometimes all of us are getting kind of busy again. So why not use this 1 hour we have to study together? Okay.
So here a quick point is HTTP and JSON are the formats for communication, even between web application and web server, right? It's just not for mobile application, though they wrote that section under mobile application, the thing we just finished. Yeah. HTTP.
Right. Yeah. So this is like that last point, right? Like a RESTful server pretty much can be sent to any client, right? And so any client can consume like this kind of data, JSON data. So that would be a web browser or a mobile app. And here's the image example of that database, right? So the database, for me, like this was sort of the longest, this thing took the longest time, this thing took me the longest time to understand, like in my career, because like, that person would say to me, "Oh, isn't HTML, CSS pretty easy?" It is, right? It's, it's not difficult for people to learn. But I think like the concept of saving information and then keeping it accurate is very difficult. Like, and that's something that isn't really taught very well in a lot of like, these front end courses or boot camps. It's more just about like the presentation layer. But, and then my always like when I was learning this stuff, right? Like they would always teach us like the presentation layer stuff, including the JavaScript, but it would be like very basic JavaScript. And then they would end the course by saying, yeah, like this is not a real world example. So you would need to like learn about databases and saving your information because we're just playing with fake data or fake dummy data. And I was like, oh, teach me the database stuff too. So this part's really important. And so, like I think like here he kind of talks about it. He says, like so at the most like, and this is me like explaining it, but I feel like at its most like simplest level, right? The database is just like, it's a point to save like whatever information you've got. So if you want to save like, like a user coming to your website, right? Like you can save that person's name, email, everything, like whatever you ask them, like in a HTML form, you can save it and then you can retrieve it the next time. You don't have to like hard code it anywhere. And so that's a really cool thing about a database. Like it's just like this open storage, like almost like a hard drive, right? Like it keeps track of this information for you. But it gets complicated when you have to, think about databases in relational ways where you have to like say, okay, well, I'm not just storing random stuff. Like all of these pieces are connected together. Users are connected to comments, to posts that they make. And so when you start having to redesign the site in that way, it's almost like rather than starting with the presentation layer, you should start with the database first. So like for any new project that, like I do, we always try to like, or I always try to start with the database work and the relational work first, because then that makes it easier for me to like do the presentation layer. I don't know if that makes sense.
Even in our development, we do start with the data layer itself. How does data be represented, and what are the rows, and what is your entities there, and then develop pieces ground up. That helps us to figure out how we can do the top level application based on the APIs we expose on the data layer. So we also do,
Right. What about you, Sadhana? Have you had a lot of experience with databases?
Yeah, so that's exactly how we go about. Otherwise, it'll be like what do you say? From the front end, you never know what will be the APIs which will be exposed, or what is the data you can expect, or what is the format in which it will be handed over to you. So it's going to be a lot of chaos if you start from the presentation layer or the UI as such.
Yeah. Okay. Yeah, that's good. I mean, like, I think that's pretty much like, like my own take and experience on this is like, as I got better as a developer, I started feeling like, yeah, database first and then the client, because it just makes more sense for, scaling and building a real like web application as opposed to just a simple website, right? So, and like he says that here too, with the user base, one server may not be enough. We may need multiple servers, one for web, mobile traffic, other for databases. So, separating these concerns allows for things to be scaled independently. There are two types of databases, like a relational database and a non-relational database. People usually think of like SQL and Mongo like as those differentiators. There's the term RDBMS, and then we know about MySQL, PostgreSQL, Oracle. And we've gone through a lot of this in the other book as well. Like we know about what those kind of operations that you can do are on the SQL side. Then you also have non-relational databases like Cassandra, Neo4j, which we saw in the other book, CouchDB. And then some of you are probably familiar with Amazon DynamoDB. We have key value stores. We learned about that. Graph stores, column stores, and document stores. Column stores and document stores probably, well, document stores is MongoDB. Let's see here. So this part here kind of talks about like the reasons why to choose a relational database or a non-relational database. So this part says they're the best option because they've been around for the most time and they work pretty well. So like if you start a new website, most likely if you need a database, and if it's just a simple site, you can probably use relational. But that said, a lot of simple sites now are starting to use non-relational too, because it says if your data is unstructured and you do not have a lot of relational, if you do not have a lot of relationships, then non-relational might be the right choice. So this is like another interview question, like when do you use relational over non-relational? So this probably could bookmark this page. Any questions up to here?
Super low latency in terms of write or read. I remember from our previous book, it's write heavy applications where we need to write and exit faster. Like your application requires super low latency, right? It can be either for a read or a write. I was under the impression if you are.
Let me just look up this term once more, just to be very careful with latency.
Yeah. Latency is the read or a write latency. But I'm thinking NoSQL was more for write heavy applications.
Yeah. So the term here is basically, I wanted to be careful, but the term just basically means like the delay before transfer of data. So maybe it's just like that first like moment when it's trying to get data, like maybe the response could be faster from something non-relational. And that makes sense, right? Because a relational takes more time to do like joins, whereas non-relational doesn't. It's unstructured, so you get your payload faster. I think that's sort of the selling point. So maybe that's what it means.
Okay. Yeah.
And you only need to serialize, deserialize data, right? And a lot of this stuff too, right? Remember the other book, we were saying that when we get JSON, like the difference between like using something like MongoDB, a non-relational database versus a relational database, is that like in the relational database, like SQL, you depend on the server to like sit and think about creating a response and produce the correct, response with types. But the non-relational one basically just gives you back like a data dump, and then you make the application itself use language to parse it.
Yeah. Schema is handled by the application layer, not necessarily the DB layer. Yes. Yeah.
Correct.
Yeah.
So that could be the reason for super low latency.
Yeah. Makes sense.
Cool. So the next part is about vertical scaling versus horizontal scaling. We touched about that in this last chapter that we just started reading, the other book. Whenever I think about vertical scaling and horizontal scaling, I just think of, like this place called Best Buy. I don't know if you have that in India, but it's like a technology store. And all the trips that I've gone there, right? Like, so every time like I say, oh, vertical scaling, I think of myself buying like a big new like MacBook fully loaded, right? With all the high CPU, all the memory, everything, like the top of the line, like Apple MacBook. And I think this is going to last me like 5 years or 6 years. I'm future proofing, right? Like I'll never have to buy another computer again. It's going to cost me, $4,000 right now to buy it, but it's worth it because I'll have it for 5 years. And then 3 years later, I'm like, oh, I want a new computer. So in like all those times I've done that, like I'm like, oh, like it wasn't worth it for me to buy such a, top of the line computer. Is too expensive, because like the basic ones can do pretty much all the same stuff. So like this lately, I've been starting to buy like smaller, like simpler computers, and then spread my workload out, right? Because like when I started making this group, I was like, oh, I needed one computer that's like just really awesome. And then like it turns out that, if I was doing some video editing or something, right, that big computer would just sit there and like be unusable for like the rest of the day. And then I'd be like, well, I still need a computer. So then I'd have to buy like a second computer and then use that. And so I started just getting smaller computers over time and like having one machine for dedicated video editing, one for web browsing, one for studying, one for data structures and algorithms. So I call that my horizontal scaling. So
Wow.
that's how I like keep track of these two like terms in my head. I don't know, like making stuff relatable is like how I kind of like remember this. But like, yeah, so here he says vertical scaling is to scale up, means process of adding more CPU, RAM. So just think about that like the next time you like are going to buy a computer, like you're just like, oh, maybe I'll get the new one. You're doing vertical scaling, where like you can probably get by with less, right? And I think that's kind of the thing that they always say, like you probably don't need the high performance one. You can probably do everything you need. Like you don't need to vertically scale up and get like the whole thing. So that's my little helpful example. So this guy says that, like when traffic is low, vertical scaling is a great option. And the simplicity of vertical scaling is its main advantage, right? Like if you have a pretty good machine, right? And they allow you to do this also in the Amazon AWS, right? Like when you're picking like an instance to run, like if you use EC2 as a service, you can pick a nice machine. And sometimes I do, like if I'm gonna like build some server, I'll ask for like pretty good specs. But like he says, it comes with a lot of limitations because you get to a limit where it becomes expensive and you can't add more CPU and memory, right? You're kind of stuck with what you get. And so like you may have points where it like kind of like does become a blocker. And then yeah, if this machine fails, you're in trouble, right? If the whole server goes down, then you have to start from scratch all over again. And that's, again, kind of going to the point about these things, right? Like every time I buy one of these new MacBooks or whatever, I have to do the whole thing again. Like backing up process is not very good. Like it's not easy for me to just say, oh yeah, this is what my last MacBook looked like. Just copy that. Like there are certain things I have to do in order to restart it. So it's annoying. So horizontal scaling on the other side is desirable for large organizations, right? Because you just have like multiple servers and you can designate each server to do some task. And, this is more like true to like the real, like the FANG companies, all that. They all have like multiple servers. This guy, Mark Zuckerberg, was saying that he has like thousands of servers dedicated to AI now. And like he's like super happy with his latest translation AI project, I think that he did. And this would be something for you to check out too, I think. So you might want to check this out, Ramya. Like I think, let me see, Mark Zuckerberg translation and project. He was saying
it was
something.
his personal project, right? Or I remember
Yeah.
he was okay.
He was saying that there's a project that he's working on, which is an AI assistant. Maybe it's this one, Cairo, but it's basically, I don't know if it's this one, but there was one that is a universal speech translator. Here, I'll
Okay.
put this in the chat. And he was saying something about like how this AI that he built with his army of AI servers is basically strong enough to like translate all the world's languages at the same time in a matter of minutes. So if they produce a new post, they can depend on their AI to accurately translate everything like to all the languages of the world and distribute it. So that's huge game changer for them because that'll help them with their advertising.
Yeah, the language models have caught up a lot in the last 3 years with GPT techniques. So yeah, they might just scale it up and have it. Facebook has a ton of data nonetheless, being like having more than 1 billion user base. So the training data is kind of freely available for them.
Exactly. Yeah. So it'd be something good to take a look into if you're interested.
Yeah, definitely. Thanks for the link.
So let's see here. So let's see. I think these are kind of like the so the last part here is about a load balancer. So let's see here. If users are connected to a web server directly, some users will be unable to access the website if it's offline. But if many users access the web server simultaneously and it reaches the web server's load limit, users experience a slower response or fail to connect to the server. So, you know, a load balancer is like a good technique. And so like this part talks about like balancing, you know, incoming traffic. So that's what a load balancer does. It balances the incoming traffic and designates it from going to one server to another, right? And so that's what, you know, makes up for like the, you know, the difference between the vertical scaling and the horizontal scaling. So we have this image. Here's a website requesting a the IP address, the DNS. So it's a web browser looking up a particular URL, then going to that IP, but then the IP has the load balancer in between, and then like, it decides whether to send the user to this server or that server. And so very useful. It says users can connect to a public IP of the load balancer directly. Web servers are unreachable directly by clients, which, you know, like you can see here too, that are now inside of a private mapping. And this DNS now resolves only to the load balancer here. Private IPs are used for communication between servers, and so that improves security. And so here he's just saying unreachable over the internet. After a load balancer and a second web server are added, we successfully solve no failover issue. And that's just because like now, like we have more intelligent, you know, like means of giving people a response. They don't have to wait for a response off of a vertical machine. And again, it makes sense, right? Like it just, most of this should make sense. You know, like if server 1 goes offline, all the traffic will be routed to server 2. You know, we can also add more web servers like in the background, which is part of the horizontal scaling. So like as, you know, like our traffic grows, right? Like we see, oh, there's a lot of traffic coming. We can just continue to clone each server and make more servers available and let the load balancer algorithm handle the delegation of which machine goes up. So that's this part here. You only need to add more web servers to the pool, and then the load balancer automatically sends requests to them. So the web tier looks good, but what about the data tier? So like the current design only has one database, and it does not support failover and redundancy. So database replication is a common technique to address those problems. So you can see here, like maybe back over in the other example, there was only one database. But, you know, like we learned in the other book, you may want to have multiple databases to solve this problem here. So any comments, questions?
Yeah, one comment is like here from the picture, if we go back, load balancer is again a single point of contact, and it may fail and cause unreachability to the web servers, right? So typically load balancers are also, they are scaled. Like server 1 and server 2, we will have a layer of load balancers in practical applications.
And then AWS, right? Like you have geographic regions too, right? So
Yeah.
because if one region fails, then you'll have multiple other regions that your machine or your users can go to.
Yeah. So typically, like there is a dotted box, and we have server 1 and server 2. Same in the load balancer, we'll have a dotted box and multiple load balancers, or there is no single point of failure in load balancer. Again, they have redundancy even in the load balancer layer.
Mm-hmm. Yeah, exactly. And it's funny because, well, not funny, but like it's interesting like how this works, right? Like when something happens, like a major event, like then maybe sometimes like there's a huge amount of traffic like to one geographic region. And so then it becomes kind of difficult for the web app, to keep up with the changes that are coming up all the time. So, as we start learning about this, I feel like it's going to be good to just understanding things like those examples that we saw in the beginning of the other book, right? Like the Twitter fan out example and all that. Like how did they handle those problems? So let's see here. So basically, I think like this part here is just talking about like replication, like master-slave relationships. Basically like the leader computer and then the follower computers. The master database only supports write operations. A slave gets copies and then does read operations. So all the data modifying commands like insert, delete, or update must be sent to master. So here's a diagram. Here's a web server. Here's the write. And then these are the web servers reading from the copies, right? So this master here is sending data to database 2, and then it's also replicating to database 1 and database 3. Most applications need to be able to read faster than write. So the number of slave databases in the system is usually larger than the masters. Here's, again, an example. Advantages with database replication: you just get better performance. You have reliability. You have high availability. And these are terms that we should remember by now. Like performance, I think it's pretty straightforward. Reliability, we just talked about sort of if there's a disaster, earthquake, the data is still preserved. You don't need to worry about data loss. And then high availability means like if you have it across different locations, these servers, right, then your website can remain in operation even if one database goes offline. You can get the data in another database. I think this makes sense, this last point, because, I'm sure all of you too, like must copy a lot of your important files. Like, if you have, important banking documents or something, you won't leave it on one computer. You'll probably like copy it, put it into the cloud as well, or like save it, to another machine, just multiple copies. So high availability when you need it, right? So these are terms to just keep in the back of your mind. Then basically here, he's asking, what if one of the databases go offline? In the architectural design, like this one right here can handle, the case of like the database going offline. So if one goes offline, then the redirections will be directed to the master database temporarily. As soon as the issue is found, a new slave will replace the old one. If multiple slaves are available, then reads can be redirected to other machines. So like if there's only one slave and if that one goes down, then yeah, we have to replace it with a new copy. And so we have to point everything to this master. But if there are multiples, then we can just point our read traffic to this next one or the next one. And then we can grow the scaling over time this way. So that's the horizontal scaling. If the master goes offline, a slave will be promoted to be the new master. And we saw this in the other book too. We were talking about leaders and followers. So
Yeah.
I think this is the same discussion here. And basically all the database operations will be temporarily executed on the new master database. The new slave will replace the old one. In production systems, promoting a new master is more complicated as the data may be not up to date. So the missing data needs to be updated by running recovery scripts. And so that's like our snapshot discussion. Where you have a snapshot, and the snapshot basically says, hey, I remember I'm good up to this point. I just need to have the system do like a write or read ahead log, and then basically bring me up to speed, something like that. Multiple masters in circulation can help. Those are more complicated. Those discussions are out of the book, but we're reading another book, so we kind of have an idea of what that is. Here is another figure. So basically here, load balancer, servers, and then we have like the horizontal scaling for the databases. So this is a full system design full improved system design meant for handling large traffic and large reads and writes. Any questions or comments up to this point?
I think the diagrams are really good here. They break it up into, they build it up from figure 1, right? Like now it's figure 6, a simple web server, then web tier, load balancer, now data tier. So it's pretty good.
Yeah, I agree. It's very simple too. I think like this book feels a little bit simpler, like to read. It doesn't feel like a huge journey. You just get the information that you need like kind of quickly. So points here is that, like again, a user gets the IP address from a DNS, which is now connected to a load balancer. The user connects to the load balancer with this IP address. The HTTP request is sent to server 1 or server 2. A web server reads data from a slave database. A web server routes any data modifying operations to the master database. This includes the write, update, and delete operations. So here you can see them on this side. This is for writes, and these are for reads. So he says, now you have a solid understanding of the web and data tiers, and it is time to improve load and response time. So this can be done using cache layers and shifting static content to the CDN. So first part is cache. So cache is a temporary storage area that stores the results of expensive responses or frequently accessed data in memory. So requests, the next time we ask for these requests, they get served more quickly. It says in figure 1.6, every time a new web page loads, one or more databases are executed to fetch the call. So boom, we get all the way down here. The application performance is greatly affected by calling the database repeatedly. So a cache can help mitigate the problem, right? You don't want to make every request ping the server. A cache tier is temporary data layer, much faster than the database. The benefits of having a separate cache include the better system performance, ability to reduce database workloads, and ability to scale cache tier independently. So here is a web server, here's the cache, here's the database. So, were you going to say something?
In my previous interviews last year, I got asked what are the different caching strategies, just out of the blue, like read through cache, write through cache, write aside cache. So it may be good to, maybe we'll make a note to read about different caching strategies.
Could you put those 3 bullet points in here? Just
Yeah.
like add them. That way
Yeah.
we'll remember those terms.
Yeah.
Okay. All right. So again, yeah, here's a diagram. If the data exists in the cache, read from the cache, return the web server. If it doesn't exist in the cache, save data to the cache. And this is like a project in itself, right? Like building a good caching system on top of a database. You know, like you need one engineer to kind of like look through this and make sure that whenever requests come through, there's a strategy in place to be able to cache subsequent calls to the same database call. So here he says, web server first checks to see if the cache has the response. If it doesn't, if it does, then it gets sent back to the client. If it doesn't, then it queries the database and then stores the response into the cache and then sends it to the client. This is called the read-through cache, just like you said. Other caching strategies are available depending on the data type and size and access patterns. So let's see here. A previous study explains how different caching strategies work. And that might be the thing to go take a look at, reference number 6. Cache servers is simple because most cache servers provide APIs for common programming languages. This is a Memcache API right here. So cache set my key, hi there. Good for 3,600 times seconds. So 3,600 seconds. Basically, yeah. Here, this is how you set the cache, and then this is how you get the cache. These are considerations. Use cache when data is more read frequently, but modified infrequently. So this is when you'd want to use a cache. Since data is stored in volatile memory, a cache server is not ideal for persisting data. And so this basically means like if the cache has to restart, all the data is lost, right? So it's not going to be your source of truth for retrievals, right? You probably do need to like have the database along with the cache. So the database will be the single source of truth. There's an expiration policy. The expiration is like probably what this points to. So once cache data is expired, it's removed from the cache. When there is no expiration policy, then it gets stored permanently. They say don't make your expiration dates too short, but then don't make them too long because data can become stale. So then you want to use caching for consistency. So inconsistency happens when data is, like data modifying operations on the data store and cache are not in a single transaction. So basically just like when the data is out of sync, like between the database and cache. So this can happen because of like modifications or scaling, like multiple regions. So, like as you scale a website, the cache has to keep track of like multiple regions, multiple servers, multiple databases. And so that is also a project in itself. You might want to take a look at scaling Memcache Facebook, as the author recommends that. So I can put a link to that as well. Coming back to this. We need to think also about point of failure. So cache is good when basically, like, well, here he's saying that, if you have a single cache server, it can become a single point of failure, which is an SPOF. So you may want to consider multiple cache servers to avoid SPOF. So this is just, again, kind of going in the same direction that we've been talking about. Like, he starts off with one single instance of something like a database or, a server. And now this is a single point of a cache. And so if the cache fails here, then we want to have multiple caches. So it's the same concept here. You see that with this example here. The router in this example is the single point of failure. So yeah, again, like, any questions here so far? Comments? Okay, so the next part is an eviction policy. So basically, like, if the cache gets full, then we're not going to be able to like add any more things to the cache. So it's going to just reject further additions to the cache. So this is called cache eviction. So there's two types of strategies. There's called the least recently used strategy, and it's basically well, I guess you're going to get to it. It's called LRU. The other eviction policy is called least frequently used, LFU, or first in, first out. So those are probably things we'll have to go and take a look at. But essentially, these are strategies to, manage cache. A CDN is kind of, the other point he was making, caching in CDN as you scale. CDNs are meant to handle content that doesn't change that often, like an image or a video. CSS files don't change that often. JavaScript files actually do change a lot, in my opinion, but they can still go on a CDN. So dynamic content caching is a relatively new concept, but it enables caching of HTML pages that are based on request path, query strings, cookies, and request headers. So basically, at a high level, when a user visits a website, the CDN closest to that user will deliver, this HTML, CSS assets and all that. So here's client 1, client 2, here's the CDN. So they're going to get their image faster from this than from the origin server. So it makes sense to put on a CDN. Here's another flow. User A gets an image, and then they, if it's not in the CDN, they get the image from the server. They put the image in the CDN and then return that image. And then the next user doesn't have to hit the server. They just hit the CDN because it's already available in the CDN. So it's also kind of like a cache in the same idea. So the further users are away from CDN, the slower the website loads. So if CDN servers are in San Francisco, users in Los Angeles will get faster content than users in Europe. And then over here, this just explains the diagram that we were just going through. So let's see here. Yeah, it's basically kind of saying the same thing here. It says URLs would look like on Amazon and Akamai CDN. So here's CloudFront, and then this is Akamai. So like if your image lives on CloudFront CDN, it would have this address. If it lives on Akamai, it would have this address. If the CDN does not have an image in the cache, the CDN requests the file from the origin, which can be a web server like Amazon S3. And then there's also an optional HTTP header time to live, which describes how long the image is cached. So this is useful if, in the same way as if you're thinking about like the expiry, like as you were in the cache, then you would want to use TTL as your point of reference. So the image remains cached as long as the TTL is still healthy. If it expires, then the image is removed. Let's see here. So the last part here, I think before we break, is why should you use a CDN? Well, CDNs are, like they're good for what they do, but when you are using them, you have to consider that you're charged for data transfers in and out of the CDN. So that could be expensive in some ways. Caching infrequently used assets provides them significant benefits, so take them out of the CDN. So don't put everything in your CDN. Have appropriate expirations for time-sensitive content. Cache expiry is important. If it is too long, the content may not be fresh. If it is too short, it can cause repeat reloading of content from origin servers to the CDN. So just be careful about how you cache. Then you should also have a fallback, because if your CDN fails, there should be another horizontal scaling solution for a CDN. So you can also remove files from the CDN before it expires by performing one of the following operations: invalidate the CDN using objects, using APIs. You can use object versioning to serve a different version of the object. To version object, you can add a parameter to the URL. So this is version number 2 for the image PNG here. And this last part here just kind of talks about like the design of how all this looks with the CDN. So now, like in this image, we've added the CDN here too. So when users make requests, the first time it'll go down the rabbit hole to the server and probably return back a response. But on concurrent requests, it should go to the CDN. So I think we can stop here, stateless web tier. Any questions or comments?
There's a very good introduction read, Vijay. Thanks for reading it. I think this is a lot more simpler. Yeah.
Mm-hmm.
It's very simply put. I mean, all our basics, we've used it everywhere, but the way they've picturized it with that, the way they've developed from one small thing to this one, right? It's nice, interesting to read. As you said, it is less strenuous to read this
Yeah.
book.
I think this book is simpler because the other book, we spent so much time on it, and we remember all those things from that book, but like here it's definitely like more organized.
Most of it we would have used. I mean, most of it we have definitely used. It's pretty intuitive, or maybe because it's the first chapter we feel it that way. I do not know, but the other book contains a lot of things which we have never used, right? I mean, practically. I mean, we might have read somewhere, but we never use it. So that's why it is a lot more time consuming. Yeah, exactly. Yeah, this one gets to the point right away, which is really good.
Yeah, this is really a good introduction to everything. Yeah.
Mm-hmm. And I love these. I mean, usually I'm a person who loves these diagrams. The diagram, I feel like it kind of registers in my mind better than reading pages and pages of.
Yeah, of course. All right. Well, I think we did a good job today. If anyone wants to, if anyone wants to summarize this and add it to Amalia's notes, or just make another notes, those are fine. Or we can just kind of like continue reading. I think like so next week, basically continuing with the plan is just we'll continue to read DDIA, which is the other book, and then we'll, come back to this on Fridays. So, and then that should make it go by a little bit better, because I feel like this one helps us organize our thoughts. And the
Yeah.
other one is useful for just exploring and learning about. Because like in my point, I feel like with the other book, even though it's more tedious to read, you learn a lot. It is really like a journey. I mean, like you get to like learn a lot about things you've never heard of. And even if you never use those technologies, at least you have some kind of, like if somebody starts talking about graph, like,
Absolutely. And that foundation is very much required. Even when we
yeah,
have to take a decision, right? We might not remember the internals or the complete things, but pretty sure after one or two passes, right, we'll definitely remember, hey, there's something related to this which I've read, or something will strike our minds for sure.
exactly.
So to just go back and read at that time, it is going to be a lot more simpler than this one. So there is no doubt about that. The value add that book gives is simply amazing. There's no
Mhm.
question to it.
Yeah, that is more for our personal growth and understanding, and even in our day-to-day job we can do better or understand things better. And this, I think, is more geared towards interview preparation. The second book
Yeah.
is, give pointers and give the required details so we can finish a system design interview in the given 45 minutes.
Correct. Yeah. Okay. Well,
Cool.
good job,
See you all.
everyone.
Yeah,
Mhm.
see you all next Wednesday. Bye.
Okay.
Bye bye.
See you all. Bye.